In this lesson, we will look at circuit breakers, which have mostly replaced fuses as the circuit protection devices in both direct current and alternating current circuits on modern aircraft. Circuit breakers combine the function of fuse and switch. They can be used for switching circuits on and off in certain circumstances. Generally, the circuit breaker incorporates an automatic thermosensitive tripping device. Once tripped, a circuit breaker usually has to be reset manually. Circuit breakers can be tripped and reset any number of times, but remember that a tripped circuit breaker should only be reset once. If it trips again, the fault must be dealt with before another reset attempt is made. Some larger circuit breakers may also include electromagnetic and reverse current tripping devices. As with fuses, circuit breakers are current protection devices and are rated in amperes. Small single-button circuit breakers are rated from 1 to 45 amperes, whereas large circuit breakers can be rated up to 600 amperes. The flight deck of a modern aircraft will have a circuit breaker panel or panels, where numerous small single-button circuit breakers will be located. These circuit breakers fall into two groups, known as trip-free and non-trip-free circuit breakers. If a non-trip-free circuit breaker is held in by the pilot under fault conditions, the circuit will be made. This is clearly dangerous. If a trip-free circuit breaker is held in under the same circumstances, the circuit cannot be made. Almost without exception, the circuit breakers on the flight deck of your aircraft will be of the trip-free type. In a typical trip-free circuit breaker, as shown here, a latch mechanism is being controlled by a thermosensitive tripping device, in this case a bimetallic strip. With the circuit breaker in the closed position, current flows through the main contacts, through the bimetallic strip and onto the load. If the current flow becomes excessive, the bimetallic strip will bend as shown, opening its contacts and releasing the latch mechanism. This action will open the main contacts and cause the push-pull button to pop out, exposing a white band on the button shank to aid identification of the trip circuit breaker. If an immediate reset attempt is made, the current will not flow in the circuit, because the bimetallic strip contacts will still be open, and the button will not latch in. Only when the bimetallic strip has cooled sufficiently will the circuit be able to be completed again. This type of circuit breaker can be used as a switch by pulling out the button. This will override the latch mechanism and open the main contacts. If a circuit breaker has been pulled for maintenance purposes, then a clip with a red flag attached is affixed to the shank to warn personnel not to reset it. Larger current capacity circuit breakers may have both a trip and a reset button. These circuit breakers are not normally accessible from the flight deck. Reverse current circuit breakers, or RCCBs, are fitted in direct current circuits to prevent the battery from attempting to drive the generator as a motor if the generator contactor should fail closed, when the generator is not producing a power supply. The generator contactor is usually opened by the generator cutout, when it senses a reverse current flow. This is fully explained in the lesson on DC generators. In order not to interfere with this process, the reverse current required to operate a reverse current circuit breaker is high, usually more than 200 amperes. The reverse current circuit breaker contains a latch mechanism, which is holding a set of contacts closed. The latch mechanism is held closed magnetically. A coil wound around the latch mechanism produces a magnetic field, which helps to hold the mechanism latched when the current flow is in the normal direction. However, when the current flow through the coil is reversed, its magnetic field operates in the opposite direction. At a preset current level, this field will have sufficient force to break the latch and open the contacts. Once tripped, an RCCB can only be reset by pushing the manual reset button. There is usually also a manual trip button on the unit. That is the end of the lesson. Remember the following key points. Circuit breakers are rated in amperes. Flight deck circuit breakers are usually trip-free thermally tripped circuit breakers, which need to be reset manually. A trip-free circuit breaker can only be reset once the fault has cleared. Holding in the reset button will not allow current to flow in the circuit. In the event of a circuit breaker trip, only one reset should be attempted before the defect is investigated. Small circuit breakers fitted in the flight deck are sometimes used as switches. Reverse current circuit breakers prevent large reverse current flows in direct current circuits.